Hello everybody and welcome to chapter 5.3 of the Advanced Functions course. We're still on trigonometric functions. Today we'll be focusing on 5.3, which deals with the transformation of sine and cosine functions. The chapter is called something different. It is functions of the form a times sine of blah 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 blah, but that was way too long to write, so that is the title I gave it. So essentially today we're going to be trying to understand the general form of these functions and then of course learn how to graph them. So let's get started. Understanding the general form. So today we'll be dealing with the following forms: f of x is equals to this and g of x is equals to this. You should remember these two forms from last year as you have learned how to graph both of these. So essentially, we're actually going to be doing continuation of chapter 5.1, which had single transformations on them, but this chapter focuses on a combination of all four. Okay, so let's first of all talk about the different parameters that we're given. So as we know from previous chapters, A is our vertical stretch or compression. When A is greater than 1, it is a stretch. When A is between 0 and 1, it is compression. And if A has a negative symbol before it, that means we had a reflection on the x-axis. What is really important to know for this chapter is that the absolute value of A will be the amplitude. Next, we have our K parameter, which is the horizontal stretch and compression. Again, just like with any other time, if it is greater than 1, it is a compression. If it is between 0 and 1, it's a stretch. If it's negative, a reflection on the y-axis. Then we have our D and C values, which always mean the same thing. D is the horizontal translation, which for sinusoidal functions is the phase shift, and C is the vertical translation, so up or down. Also for K, it's important to know that the period of the function will be defined as 2 pi divided by the absolute value of K. When analyzing a graph function, you could actually use its key points to determine every parameter to actually find an equation. So for example, you could find the maximum minimum point, and then the difference between the maximum y value to the minimum y value divided by 2 would be your A parameter. Similarly, max plus min divided by 2 would be your C value. The distance from max to max would be the period. You could also go from minimum to minimum, but I don't know, I personally don't like to do it that way. Then you could also find the distance from the base function key point to the new key point in the phase shift. So for example, I will show you how to do these on a graph itself in the next part. With that being said, let's actually talk about how to graph the functions. So if you're given the function itself or a description of what the graph should look like, it is rather easy to graph a sinusoidal function. So for example, if you're given the function, you need to identify the amplitude, the vertical translation, and the phase shift. You don't need to figure out the period because it's usually not going to be given. So you actually have to calculate it. It's not going to be expressly given in the function. Again, the period would be 2 pi over absolute value of K. Then what you should do is graph the base function. So if you're given a sine function, graph the function of sine of x. If you're given cos, then graph the cos function. Then you should graph an intermediate function with the appropriate amplitude and period and any reflection. So apply the A and K parameters. Lastly, add on the C and D parameters and you should have your final function. Similarly, if you're given a description, you should easily be able to find the amplitude, the vertical translation, phase shift, and the period, as those will be given to you in the description. If something is not given, you could assume that it didn't occur, So if you don't see anything about the vertical translation, that means there has been no vertical translation performed. Again, you're just going to be following the same steps as before. You're going to graph a base function, the intermediate function, and then the vertical. And then apply the vertical and horizontal translations to graph the final one. So, for example, let's look at these two. First of all, we need to determine an equation for the following. A cosine function has a maximum value of 2, a minimum value of -6, a phase shift of 4 rad to the left, and a period of 1. And then we need to graph the following functions. So let's do that. Okay, so let's look at this question. First, we're given the maximum value of 2, a minimum value of -6, a phase shift of 4 rad to the left, and a period of 1. So immediately, let's just write down what we know. Our max is equals to 2, min is equals to -6. Our phase shift, which would be our d value, is equals to 4 to the left, which would be -4, and then our period is 1. So what we know is that our a value is equals to maximum plus minimum, or sorry, minus minimum over 2. So a is actually equals to 2 minus -6 divided by 2. That is equals to 4. Then our c value is equals to max plus min over 2, which is equals to 2 plus -6 over 2, which is equals to -4 over 2, which is equals to -2. We know what our phase shift is, and next we have to find our k value. Our k value we know is related to the following. So 2 pi over k is equals to the period, which is equals to 1. Therefore, 2 pi is equals to k, so k is equals to 2 pi, you know? Now that we know all of these, we could write down the equation. As you should recall, it is a cosine function, so you could say f of x is equals to our a value, so 4 cos, first bracket would be our k value, second bracket would be x minus our d value. Since we have a negative d value, it's plus 4. And then we have, it doesn't seem, for our c value, we have a -2. Therefore, the equation is the following. Now let's do these questions. So I'm going to label this 1, this is 2. So for 1, we know that our a value is equals to 2, our c value is equals to 3, d is equals to 7, and then k is equals to -0.5 pi. First, we could find the period. Again, the period would be 2 pi over our k value, or the absolute value of k, which is equals to 2 pi divided by 0.5 pi, which is equals to 4. Okay, so now we should have all of our information to draw the graph. Let's insert the graph in. There we go. Let's draw 2 cycles of it. So what should we start at? We should start by graphing our base function, which is sine. So first of all, let's write our key points. Pi, 3 pi over 2, and then 2 pi. Then same thing on the negative side. Okay, we know that our key points were 1, -1. Sorry, that's a little bit too low. -1. Sine starts over here, then we go up, down, down, up. Let's try to redo that one, sorry. There you go. Then for our second, we should have this. Now let's label this as y is equals to sine of x. Okay. Next, let's apply our a and k factors. So, let's choose a different color. First of all, we have a vertical stretch of 2. So now we need to expand this. We got to these points. Our zeros stay the same. Now our period was also changed. I know before it used to be 2 pi for 1 period. Now 1 period is equals to 4 radians. Since we know our period is 4, we actually need to work with our x-axis a little bit more. So for example, since we had everything in pi's, we actually need to find the round measurement in radians. So pi over 2 is approximately 1.5, pi is 3.14, 3 pi over 2 is around like 4.7 if I'm not wrong. So essentially 4 should be over here. If 4 is over here, we need to divide this into, first of all, a half, and then our up and down, right? Because we need to go up and then down for a sine function. With these 4 points down, we could actually start to graph it. We're starting from a 0, go to our 2. It's gonna be a little bit difficult for me to draw it well, but this is around what we're getting for one part. Again, we said -4, so let's divide it in half, and then half again, so let's see that. Down, and then up. Okay, so that's our intermediate graph. Now, the important thing to notice here is that we had negative 0.5 pi, which would mean we actually have to reflect this on the y-axis. I will do that as a second intermediate graph, but if you want to do this all in one step, you could. So now all of our points will get reflected, right? So this point and this point are now here. And this point is not here, and this point is not here. So let's do that. I'm gonna try to do this a little bit faster so we don't waste time. There you go. So I'd label them. I know it gets a little bit confusing when you have so many graphs on such a small canvas. So this would be 2 sine 0.5 pi x, and our gray graph would be y is equals to 2 sine negative 0.5 pi x. Lastly, we need to apply our translations. We'll do them in black. So let's do that. We are moving up 3. So we were at 2, now we need to go all the way to 5. -2 would go up to 1. That's good. Then we have 7 to the right. Okay. What you could do, of course, is just translate everything by 7. So let's expand this graph over this way. It's really a bad straight line. Let's do that. It's better. So let's see, 7 is around, let's calculate. We know that 2 pi is around 6.28, so then we could graph 5 pi over 2, which is around 7.8, so we know 7 should be around somewhere in the middle, so it's over here. Okay, so as we said, 7 should be around here, so let's plot 7. We know that 7 used to be the point where we go downwards. So 7 should be at 3, and then we go down halfway through it. Again, this distance should be the same as here. We go down until 1. Then we're going up until 5. This doesn't seem like it's at 3. Sorry, let me fix that. 3 is over here. Then to 1. Let's graph one branch like this, then the second branch going this way. Again, you need to make sure that the distance between all of these are the same when you're actually doing it on a graph paper. Now that we have this, we could draw a graph. Okay, so now since we're moving by 4, we know that this should be 3, 7. This should, this should be 7, 3. I wrote that the wrong way. 7, 3. This is 4 this way, which would mean this is 3, 3. Let's see if that is true for when we graph it on Desmos. So here I graphed the graph itself. As you could see, for example, let's go to 7. It is at, come on, 7, 3. That's the point we got. Then we're going down to 1, and then up to 5. That's good. And then I said over here, we should go to 3, 3. Yep, that's good. So this is the cycle that we drew. As you could see, it looks a little bit wonky, but the idea is still the same. We didn't continue a cycle to the point where it reached 0 and 1, but it should reach it. As you could see. Lastly, as you could see, again, everything we've done was correct. And so you could always do this at home to check whether or not your graphs are right. Again, I would recommend not doing the green one as it could get confusing. But if you feel like it helps you, then go for it. Now let's do the second question. So our second question is pretty simple. Sorry, I'm gonna move this down. There you go. We have a is equals to -5, k is equals to 2, d is equals to -0.2 pi, and then c is equals to -1. Let's figure out what our period is. So our period is 2 pi over absolute value of k, which is equals to 2 pi over 2, which is equals to pi. So everything else was given to us. So again, let's make the graph itself. There we go. Let's label our points. -3 pi over 2, and then -2 pi. Here we have the same thing, use positive, pi over 2, pi, 3 pi over 2, and then 2 pi, 1, -1. It's a cosine graph, so we're starting at a vertex, going down. Sorry, wrong spot. Our graph would look something like this. Again, going down. Okay, so this is y is equals to cos of x. Now let's apply our a and k values. We see that a has a negative in front of it, so we're immediately reflecting it in the x-axis. So let's see what happens. We're actually going all the way to 5. So let's mark this out. 2, 3, 4, 5. Also, this -1 is way too low, but that's okay. We could work with it. Make sure your units are actually proportionate to one another when you're doing it on a test. But since here we're just doing an example, I'm not too worried about that. Now, okay, I expanded it here. So 1 turned into -5. So all of our vertexes are now over here. We also have pi as our period. So since we know our period is pi, let's place a point at pi -5 since that is our new minimum point. We also know that in the middle of it, we should have our second point, right? And then in the middle of those two, we should be crossing the x-axis. So our graph is going to be much skinnier compared to the original graph, but that's not a big deal. So this would be branch 1. And then again, let's do the same thing. So at -pi. And then over here we reach to 5. And then in the middle of these, we have our zeros. There we go. This is y is equals to -5 cos of 2x. Lastly, we'll apply our translations. So we move down to -1. So now our minimum point is at -6. And then we also moved 0.2 pi to the left. 0.2 pi would be 1/5 of this distance here. So around, I would say that much. There you go. These are our new points. I'm just going to circle them to make our life a little bit easier. Again, we move down to -1, so this point is now over here, and then new point to -1, and then over here. That's good. Lastly, our middle points are just moving this way. Again here. Let's graph this function. Sorry, that's not right. Let's start from the vertex over here then. We didn't move these ones down, so I forgot about that, but again, that should be moved down because now this is the line that we should have our C value. There we go, cross that line, go to our new lowest point, come back up, reach our maximum. And then reach our second. There we go. So this is y is equals to -5 cos 2x plus 0.2 pi minus 1. I know it is a little bit confusing and not that visually appealing to see these graphs drawn out like this. I understand it might cause actual more confusion, but there's not much I can do besides just explain how to do this. So try not to pay too much attention to the technical aspect of how I'm drawing the graphs. Try to understand why I'm drawing the graphs this way. Again, let's look at whether or not our graphs correspond to Desmos. Okay, so I've graphed both of them again. Let's see what we have here. As you can see, we do reach -1, right? There you go. This is the middle. We have -6. This is 0.2 pi, which we know should be correct, right? Because we moved over 0.5. Again, let's just look at the two graphs side by side, whether or not they agree with each other. We could definitely see that it got compressed by 1/2. I could see over here. That's pi. This used to be 2 pi, so we did that correctly. Our vertices are at 4. Yep, that's good. And at the bottom is -6. Again, this should be 0.2 pi over, which is exactly what we did. Therefore, our graphs are correct. Now with that being done, this is the homework for today. It's all just practicing your derivation of equations and how to graph these equations as well. It should just be extra practice for something you've been doing for a couple of years now. For that reason, again, we'll not be going over it, but if you have any questions, feel free to contact me. Also, what you could do is always just make your own equations in Desmos. Don't look at how to graph them yet, and then try to graph them yourselves. And then again, Desmos, just turn it on and then it'll show you whether or not you got your solution correctly. With that being said, thank you for listening. I know this class is pretty short. This whole unit is actually pretty short to me. I hope you had a lot of fun listening, and I'll see you next time.